Converting logs, chapter 4.5. Whenever you have a log of the same base equals a log of the same base, you want to kind of condense it so that you just have the log of something equals the log of something. And then you can cancel out your logs and solve the something. So here I'm going to use the power rule, and I'm going to bring that 2 up as an exponent to x. So I have log base 5 of x squared equals log base 5 of 9. And this only works when your log bases are the same. So if your bases were different, you would have to use the computer calculator, Desmos, something like that. So cancel those out and you get x squared equals 9. Take the square root, you get x equals plus and minus 3. Now remember, you can't take the log of a negative, but because we have this 2 out front, it won't be negative, so boom. Questions on, because of the 2, so it'd be like, even if you square it, it's not going to be negative. So it'll be positive 9.
Oh, I didn't even realize it was 2.
Oh, you see it now? Okay, good.
The 2 just kind of disappeared in the problem.
My OLP people are probably having a hard time following all that. All right. So the next one, I want to condense it so that I get 1 log, and then I can convert it to exponential form. That's my favorite way to do it. So remember, addition translates to multiplication. So I have the log base 4 of x plus 3 times 2 minus x equals 1. The sum of the logs equals the log of the product. I think I said that correctly. Then I'm going to convert that to exponential form. So remember, you start at your base. The base of your log is the base of your exponent. So 4 to the first power equals that guy. So 4 to the first equals, and I'm going to rewrite that 2 to the x. I don't know why it bothers me. I like for x to be first. And then I'm going to FOIL that out, and I'm going to wind up with a quadratic equation that I need to solve. So first outer, inner last, I have negative x squared plus 2x minus 3x plus 6. Combine my like terms, I have 4 equals negative x squared minus x plus 6. I'm going to rearrange this so that I have 0 on one side so I can solve both the quadratic formula, factoring, or graphing. And I want my x squared term to be positive, so I'm going to move everything to the left. So I'm going to add x squared to both sides, add x, and subtract 6. So I get x squared plus x minus 2 equals 0. This one is factorable, so my factors of 2 are just 1 and 2. To get my b term, which is just positive 1, I use positive 2 and negative 1, so I have x plus 2 times x minus 1 equals 0. And then I can use the zero product property, and I'm just going to go up here so I have space. The zero product property to set each piece equal to 0, so x plus 2 equals 0, and solve. And x minus 1 equals 0, and solve. I would then just need to check for any domain errors. If I plug both of these in, I need to have not 0, anything greater than 0 inside my logs. If I plug in 1, I get 4. Negative 2, I get positive 1 here. If I plug in negative 2 here, I get 4. If I plug in 1, I get 1. So those both work. Just checking to make sure. Yes, it can't. So what's inside has to be positive, not 0 or negative. Does that make sense? All right, the next one's a cool substitution problem. Are there questions on the first one or the second one there?
Oh, well, they're only 8.
Yeah, they're not many. So this one I'm going to let, and I'm going to tell you why in a second, but I'm going to let 2 to the x equal a. I can rewrite this one in terms of 2. So 4 is 2 squared, so I have 2 squared to the x minus 2 to the x minus 12 equals 0. When you raise a power to a power, you multiply. So you have 2 to the 2x minus 2 to the x minus 12 equals 0. So now these are both in terms of 2 to the x power. This one is 2 to the x squared. So it's like having a squared. This one is just a, and then I just bring down my minus 12. So what I'm doing is I'm just substituting, and I'm going to solve a different equation for a value and then set up two other equations. It's really cool. Math is fun. So now this is a quadratic equation just like we did here. We can factor this one. Factors of 12 that give me -1 are 3 and -4. You have 1 and 12, 2 and 6, 3 and 4. So I have a minus 4 times a plus 3 equals 0. Then I can use the zero product property with those things. So I have a minus 4 equals 0 and a plus 3 equals 0. Once I've got those linear equations, I can resubstitute my 2 to the x back in for a. So I can take this guy and plug it back into here and there. So now I have 2 to the x minus 4 equals 0 and 2 to the x plus 3 equals 0. And those are solvable. So this way I'm going to add 4. So I have 2 to the x equals 4. You can convert it to logarithmic form. If you're not sure, you can say log base 2 of 4 and type it in your calculator. But 4 is 2 squared, so I have 2 to the x equals 2 to the 2. So that means that x equals 2. I'm going to subtract 3. And I have 2 to the x equals -3. Now this one, there's nothing I can raise to 2 to the power of to make it negative. If you put a negative in the exponent, it doesn't change the sign, it just reciprocates it. So this one, if you convert it to logarithmic form, you can kind of look at it that way. Log base 2 of -3 equals x. And you type it into your calculator. Hopefully you see just by writing that out that you can't take the log of a negative. Log base 2 of -3. So this one does not have a solution. So our only answer is x equals 2. Are there questions on that one? That one's kind of challenging.
Anytime you see that though, if we break it down, there's like a negative.
Yes. So if you've got, unless there's a negative here and you can cancel the negatives out, that's the only way that you'd be able to do it. Does that make sense? Yeah, but if you're just questioning and you're just not sure, convert it to log form and then just type it in your calculator and it will essentially tell you. Questions on that one? So that's what we're going to do with number 4. We're just going to convert this to log form because I can't change the base of 5. 5 is 5. 5 is prime. It doesn't have any other factors. It's not a 2 to any power or anything like that. So I'm just going to convert it to log form. Log base 2 of 5 equals x. And when you do this, typically if it doesn't change bases, it'll give you a decimal. So you'll have to round. You can either use the change of base formula, which remember would be the common log of 5 divided by the common log of 2, or log base. And typically we round to 2 or 3 decimal places. It just depends on what it asks of you. I'm just going to take this one to 3, 2.322. Questions so far? Not too bad so far, hopefully. All right. This one. Number 5, I only have one thing raised to the power of x with x in there, so I'm going to undo what's happening to my exponential piece, and then I'll convert it to logarithmic form. So I'm gonna undo this multiplication. You can't say that that's 24 to the x power because you do parentheses, exponents next. So you would have to do this before you multiply. Since that's a variable, you have to undo the multiplication. So I'm dividing both sides by 8. And I have 3 to the x equals 5/8. Oh, shoot. 5/8 is 0.625, or you can just leave it as 5/8. I like fractions better than decimals, personally. Then I will convert it to log form. So log base 3 of 5/8 equals x. And then I'm just typing it in my calculator. Negative 0.428 if we round to 3 places.
Where's the,
Log base,
yeah,
hit math, and go down. I think it's option A. A, as in Amanda.
where's that?
Keep
Oh,
going.
it's at the very bottom.
Yeah.
But you can change the base.
Yeah, you can do change of base if you prefer it that way. I used to prefer it that way, and then I got used to this calculator. I don't like it. So change, if you did change a base, which is kind of outdated, you would just say the common log of 5/8 divided by the common log of 3. And you could type that in your calculator just with the log button.
Oh.
Does that make sense? Yeah, you'll get the same thing. It's just without having to go to that.
Okay.
And some calculators, if you have like on your phone, it won't let you change it if you just have that with you. But, yeah. Did you have a question, Gus? It doesn't matter for this one. Good question. That only matters when you're typing in sine, cosine, or tangent for the most
I
part.
have it here, but I changed the amp, but I don't understand how it changes the amp.
Oh, it's so cool. Because radians is a different angle of measure, way to measure angle. Radian is the ratio of the arc length to the radius of a circle, whereas angle measure we've just given these arbitrary numbers to as a society. So cool. Anyway, okay. This one's a little more tough because we have 2 different bases here. So even if we got them on the same side, we couldn't combine them. We can't cancel out because we have a base 5 and a base 3. So these exponents are not equal to each other. When you have something weird like this, I like to take the natural log of both sides, and I'll show you why this is cool. So I'm taking the natural log of 5 to the x minus 2, just of both sides. As long as you do it to both sides, it doesn't change your equation. Then you can use the power property to get rid of your exponent. You move this out as a coefficient in front of both of your natural logs. Make sure, since there's more than one thing, that you put it in parentheses. Now your goal here is to solve for x, so you want to get your x's together into one x eventually. So the best way to do that is to distribute here. I drew my arrows in a weird way, but. So I have x times the natural log of 5 minus 2 times the natural log of 5 equals 3x times the natural log of 3 plus 2 times the natural log of 3. Questions so far? So now I want to get my x's on the same side of the equation. So I'm going to move my other things away. So I'm going to move my 2 natural log of 5. I'm going to add that to both sides. And I'm going to get rid of my 3x here. And it doesn't matter which way you go. I just chose this way for whatever reason. So those cancel and those cancel. So on the left, I have x natural log of 5 minus 3x natural log of 3. You can't combine those yet. You're taking the natural log of 2 different things. Equals 2 times the natural log of 3 plus 2 times the natural log of 5. So this one right here, I just got my x terms together and my ones without x's together. So I just moved those over. So now you can factor your x's out of that left side. So you get x times the natural log of 5 minus 3, the natural log of 3. So you're just pulling out that GCF of x to get it to have 1x. Now you're just multiplying that x by what's in that parenthesis. So you can just divide both sides by that parenthesis. So then you have x equals, and when you plug this in your calculator, you need to put it in parentheses, the numerator and the denominator. And that's what you're going to type in. You can move those coefficients back up as exponents if you want, but it is not necessary because we're just trying to get a value for x. So in my calculator, I'm typing in parentheses 2 natural log, remember that's just to the left of 4, of 3, ending those natural log parentheses, plus 2 natural log of 5, ending the natural log and the numerator parentheses, divided by, in parentheses, the natural log of 5. The biggest thing when you're typing this in is just to watch your parentheses and be really careful. Because it automatically puts parentheses around what you're taking the log or the natural log of.
So what do you think around up with everything like that?
So you need parentheses around the top and the bottom because if you don't, it's just going to divide these two things together and then add those, just order of operations. So you get x equals negative 3.212 if you round it to 3 decimal places. Hate what? Oh.
Wait, so why would you not just cancel out one of the natural log of 5 and then?
Because you are not multiplying. So good question. Why would you not cancel out the natural log of 5 and the natural log of 3? You have to be like if you were multiplying these things here instead of adding and subtracting, then you could. But the adding and subtracting makes it has different rules. All right. Questions on that one?
What did you get?
Negative 3.212.
Okay.
Number 7. This one, my logs have 2 different bases, so I'm going to do it on my calculator. I'm actually going to just do it on Desmos for the sake of showing. Let's see here how this works. Oh, okay. Sorry. Minimize. Okay. Oh, shoot. I picked the wrong one. New share. This one. Okay. So this equation, we have the log base 3 of x plus the log base 4 of x. So you're going to put the left side in for y1 if you have your calculator or in one equation. And you'll put the right side in. And you'll have to do y equals 4 on Desmos. And then you're just going to see where they intersect, which is beautiful right there at 11.607.
I like that one.
Most people do. Not super hard. You want to know a cool trick? You can do that with literally any of them. So what?
Isn't the subscript on there like shift minus?
It is, yeah. It's shift and then the dash. Yes. I don't know if the minus works too, but
You're telling me you could make me just break these all out this entire time and you could have just done most it all.
you literally could have just Desmos it all. Desmos? Desmos?
I set up here because I'm not even eating Desmos, it's still none of them. So
None of
you
them
tell
are.
me that-
So you want to see something cool? I'll show you the last one. The left-hand side, 5 to the x minus 2. Oh, shoot. Just kidding. Hang on. X minus 2. And then 3 to the
Oh,
3x. Dang it. I keep 3x plus 2. And then where do them suckers intersect? Let's see. Was it at? -3. Boom. So it's harder to see on there, obviously. But if you put it in your calculator, it like shows you where it is. So yeah, totally. What was what now?
X equals
Oh, 11.607, number 7,
negative positive.
positive. 0.607. And then the last one, we have x plus e to the x equals 2. We're going to do the same thing on that one. X plus e to the x power. And then y equals 2. And where those intersect, 0.443